Okay, in the previous summary video, we looked at a compound that had a positive charge, but because of the lack of sufficient number of electrons, we concluded that the compound was not aromatic, despite the fact it had a ring and it looked like it might be aromatic, but it was not. But now this is the case. Now, this compound, as it is, contains 6 electrons, right? Because I said the positive charge itself has no effect on the number of electrons because it essentially is equal to 0 electrons. So we now have we now have 6 electrons, right? And that satisfies the Huckel's rule. But does it satisfy the alternate double and single bond? So a positive charge here means that this is like, you can think of it like what I'm gonna say here is, even though that's not how it looks, but this is kind of what positive charge does. Okay, I'm gonna go back and erase that. But what it does is, the positive charge here, you're thinking as if there is no carbon here, it's just a flat line. So double, single, double, single, double, single. Does that make sense? Okay, so I'm going to go back and erase that red line. Okay, so that means it does satisfy the D/S, which is double and single, which means the molecule is planar and it's got 6 electrons. So we do conclude that this is aromatic, right? Okay, so what does that mean? How are we going to go about doing resonance structures? Just like how we did our negative, okay, we can move the bond, this bond or this bond or this, it does really doesn't matter. Okay, I'm just going to start with this one. Okay, if I move this bond towards the carbon containing the positive charge, then my new molecule is always difficult to draw this one because of this hard shape. Okay, I'm gonna try my best. Okay, there we go. So I'm gonna do this in black because it's too much red here. I mean, this bond has not been disturbed by the movement. This here, this bond has come here, so the positive charge must go here. Okay, not here. Whenever you're moving positive charge, it must go to the tail of the double bond, so it's here. Now let's continue this process. This can come over here, which means this is the first, this is the second resonance structure. This, the original structure is one of them, this is the second. So let's continue. It's always difficult to draw these multiple times, but once you keep drawing, I think you'll get used to it. Okay, it doesn't look perfect, but it's good enough. So let's get a different color, maybe a blue. Okay, so this bond is not disturbed, it's there. This bond is also not disturbed. This bond has come here, so the positive charge must go to the tail of this bond. You get the idea, right? Now you can bring this over here, and I want you to continue and complete the remaining of the resonance structures. Okay? Okay, good. All right, so this is how you do aromaticity for compounds containing positive charge, okay? So yes, you do have to remember when to keep the positive charge. If the positive charge is starting on the outside, then every time you move your bond around, you've got to keep the positive charge outside. If you're starting with a negative charge on the outside, it's the same thing. Every time you move a bond, you've got to keep the negative charge outside. Okay. All right. Now here's something that's very important. This is naphthalene. Okay, so how do we go about, well, this is aromatic, okay, because of the 10 um, 10 electrons in the Huckel's rule, and then it also satisfies the D/S. I don't think any of you have problem with that. It's just trying to draw the resonance structure seems to be the problem. So what I normally do is I move the one containing the 3 electrons first as one as into their alternate position. So I move this here, move this here, move this here. Now keep in mind, the structure you're starting with is already one resonance structure. Okay, so now let's go draw the second resonance structure. Okay, so this bond is here, this bond is here, this bond is here, and this is here. This is your second resonance structure. Okay, now whether this bond is here or here, it means the same thing. Okay, because you move your bond here does not make it a new resonance structure. Instead, what you should do, this is pretty generic. Okay, you can apply to as many rings as you want. So the second, to get the remaining structure, you move this bond here, this goes here, and this goes here. Okay, so this bond is not disturbed. This bond is now here, this bond is here, this bond is here. That's it. If I move this, okay, I will end up with the bond here, but that is already being shown here. So what I'm saying here is this is a legit resonance structure. Okay, I'm going to show you what is not a resonance structure. Okay, let's do pink. Okay, let's say I move this here, move this here, and move this here. I am going to get okay, this might look different than anything you have, but the fact of the matter is we've already had this double bond on the bridge, and like I pointed out, whether it's on this side or on this side, it's the same thing. So if you already had a bridge, there's only one bridge here. If you already had one structure that had the bond on this side, for instance, this is on the left side, this is on the right side, okay? But the bond is on the bridge. So this does not constitute, I'm going to put it in black so that you can see, this is not a resonance structure. So you only have 3 resonance structures. Okay, so this is not happening. You stop with just this. You don't move these bonds. You can try. Unless you try, you wouldn't know if that is a resonance structure or not. So this compound only has 3 resonance structures total. Okay, now there is one problem on the quiz that you may want to fight around to get this, but I don't think there is any problem other than this on the homework. So you should have a lot more easier time dealing with these concepts. All right, now I have worked out 5 problems, and these 5 problems are pretty generic that you can apply across a wide range of concepts. And I am trying to keep the video within the 10-minute mark. All right, so this is my summary Q&A video for the concept of aromaticity. Now at this point, if you still have any remaining questions, you just have to ask me during class, and I think that's the way to go. But if you watch these 2 videos, I think you should be in slightly better shape to go about solving problems on aromaticity. All right, so stay tuned for more videos on a different concept.